Now I'm going to show you a special normal distribution, which is called the standard normal distribution. We're going to assume that x is a random variable that follows a normal distribution, where mu is the mean and sigma is the standard deviation. If we wanted to compute the z-score for any x value under this distribution, that z-score would be calculated as follows. Z is equal to x minus mu divided by sigma. In a previous lesson, we talked about computing z-scores, and we had z equal to x minus x bar divided by s. When we're using the mean of the sample, x bar, and the standard deviation of the sample, we use the formula here on the right. Now, if we have mu, the population mean, and sigma, the population standard deviation, then we go ahead and use the formula here on the left. In both of these, we're taking our observation minus the mean, and we're dividing by the standard deviation. The formulas are similar. Again, your observation minus your mean divided by the standard deviation. Recall that a z-score tells you how many standard deviations that x value, x, is above or below the mean. If your z-score is positive, that means that x is above the mean. If your z-score is negative, then that means that x is below the mean. The standard normal distribution is a special normal distribution with a mean equal to 0, and the standard deviation is, this distribution has a standard deviation of 1. You can go ahead and visualize a standard normal distribution with a mean equal to 0 and a standard deviation equal to 1. We would go ahead and draw a normal distribution curve. Here at the center, we would go ahead and label 0. Using the standard deviation, which is equal to 1, we can label standard deviations to the right and to the left. So let's go ahead and take 0 plus 1, that is 1. Let's add another 1. We get 2, and then we get 3. So we see that the z-score, 1, marks the first standard deviation to the right. The z-score equal to 2 marks the second standard deviation to the right. And then same thing with the z-score 3. The z-score 3 marks 3 standard deviations to the right. Now here on the left, we can go ahead and label the first standard deviation, which is -1. The second standard deviation, which is -2. And then the third standard deviation, which is equal to negative. Again, we can keep going, and we can label more standard deviations, but I'm just going to stop here. I'm just wanting to show you the graph of the standard normal distribution, which always has a mean equal to 0 and a standard deviation equal to 1. If we know that x is a random variable that follows a normal distribution, we can take that distribution, the normal distribution, and we can translate it into a standard normal distribution. We call this standardizing the random variable. So again, we can translate any normal distribution into the standard normal distribution. How are we going to do this? In order to do this, we're going to take all the x values of a random variable and we're going to convert them to z-scores. So again, if you have a random variable that follows a normal distribution, that distribution is going to be created with all the observations, all the little x values. We can go ahead and take all those x values, all the observations, we can find the z-score of each of those x values, and that is how we can create. So let me show you how you can do that. Let me give you an example. We're going to consider a random variable that follows a normal distribution with the mean equal to 12 and a standard deviation equal to. Here in part A, we're being asked to use the curve on the left to illustrate the random variable x that follows a normal distribution, again, with the mean equal to 12 and a standard deviation equal to 3. Once we do that, we're going to label the observation x equal to 7. So again, here we're using the curve on the left. Let me go ahead and write x follows a normal distribution with the mean equal to 12 and a standard deviation equal to 3. We're going to use the mean and standard deviation to label this curve. At the center, we're going to have the mean, which is 12. To the right, we have the first standard deviation being 15, the second standard deviation being 18, and the third standard deviation being 21. On the left, we have the first standard deviation being 9, second standard deviation is 6, and the third standard deviation is 3. Again, we can continue labeling more standard deviations, but I'm just going to stop here. The last thing we need to do is to label the observation x equal to 7. X equal to 7 is between 6 and 9, between the second standard deviation and the first standard deviation on the left. So let's go ahead and just label our observation x equal to 7. Now, let me show you how we can translate this normal distribution into the standard normal distribution. When we translate this curve into the standard normal distribution, we're going to have a distribution that has z-scores. So I'm going to write a capital Z to emphasize that those X values are being converted to Z-scores. Those Z-scores are going to follow a normal distribution with a mean equal to 0 and a standard deviation equal to 1. That is always going to be the case with the standard normal distribution. So let's use the curve here on the right to illustrate the standard normal distribution. So we're going to have 0 at the center. The first standard deviation to the right is 1. The second standard deviation to the right is 2. And the third standard deviation is. Now let's go ahead and mark 3 standard deviations on the left. We should have -1, -2, and -3. Now in part A, we're also being asked to label the Z-score corresponding to the observation X equal to 7. We need to go ahead and find the Z-score for X equal to 7. So let's make a note of that. We're using X equal to 7. The mean here is 12, and the standard deviation is equal to 3. Again, we're using the mean and standard deviation of the random variable X because we're referring to an observation coming from that distribution. The observation here is X equal to 7. So let's go ahead and find the Z-score. The Z-score, Z, is equal to, the formula says take X minus mu and divide by sigma. So let's go ahead and do that. Here we have X equal to 7. Let's replace X with 7. Mu is equal to, let's replace mu with 12. And sigma is equal to 3. Let's replace sigma with 3. We're going to go ahead and round. We should be getting -1.67. I'm going to go ahead and round here because we're going to label this Z-score on the normal distribution here on the right. The Z-score is going to be between -1 and -2. So let's just go ahead and try our best. Here the Z-score is -1.67. Here on the left, we see that the observation X equal to 7 is between the first and second standard deviation. That is what we're seeing here on the right. The Z-score corresponding to the observation X equal to 7 is between the first and second standard deviation on the left. Now, let me go ahead and make another highlight. Now, would you be able to guess what the Z-score for X equal to 12 is? What would happen if you calculate the Z-score for 12? You can go ahead and do it here. The Z-score is always going to be equal to your observation minus the mean, which is 12, divided by sigma, which is 3. And so if you're talking about your X value being equal to 12, what's going to be your Z-score equal to? You're going to have 12 minus 12, which is 0, divided by 3, which is 0. The X value equal to 12 corresponds to the Z-score equal to 0. Now, can you guess what the Z-score is going to be for X equal to 15? Let's go ahead and try it here on our formula. Here we would have to take 15 minus 12 divided by 3. 15 minus 12 is 3, divided by 3 is 1. The Z-score corresponding to X equal to 15 is 1. The Z-score corresponding to 18 is 2. The Z-score corresponding to 21 is 3. The Z-score corresponding to 9 is -1, and so on. The Z-score corresponding to 6 is -2, and the Z-score corresponding to 3 is -. What we're doing here, we're simply taking every X value that we have and we're converting it into a Z-score. And that is how we come up with the standard normal distribution. And this is the reason we say that we can take any normal distribution and we can translate that into a standard normal distribution. Okay. This is the end of our lesson. You can think of this lesson as an introduction to normal distributions. In our next lesson, we're going to be talking about how to use normal distributions to calculate probability.